several sensors are there, and we have our own Indian remote sensing satellites. We also have other countries' satellites where we use them also for our projects. And the GIS and GPS, I think most of you are already aware of. Let me go through that. Now, when we say remote sensing or geospatial technologies, what are the essential parameters which govern how to go forward in working with this data and its application? Essentially, we need to be clear on what data we require for our purpose. Which data is useful for us? So for that purpose, what is the temporal dynamics you are looking for your application? Are you interested in daily data? Are you interested in capturing the daily variations, or weekly variations, or monthly variations, or yearly variations? Accordingly, you need to choose. So the temporal dynamics, that helps you for temporal resolution of the satellite data you are talking about. And then the second is spatially. What is the spatial resolution that is required for your application? Are you working at a national level, regional level, district level, or at a city level, or for urban related applications? So at what scale you are going to work, and what is your expected output? Accordingly, the spatial resolution matters. And finally, the spectral resolution. Spectrally, what sort of fidelity is required to discriminate different kinds of features or objects? So the spectral libraries of different features will help you to understand which spectral frequency or resolution is helpful for your application. So these are the 4 parameters which help you to choose the right data set for your application. Now, broadly, remote sensing applications, if I summarize in a single word, we can say as a big umbrella, sustainable development as a big umbrella of applications. What do you mean by sustainable development? The sustainable, that means the development is sustained over years. That's what we mean. And that includes food security, water security, energy security, and shelter security, health security, infrastructure security. In addition to these are the positive part of it. And there is another one, disaster risk reduction. Now, whenever there is a disaster, how best we can minimize the risk, we can minimize the damage with the well preparedness to handle the disaster. So that is another domain. And in the
Second cam first cam
so again, I just re-emphasize, we years, and it is also available for sharing. And then climate change impact assessment, conservation and developmental activities or plans. how best we can conserve our water, because that is going to be a scarce resource after some time. Maybe the next generation will have tough time. So how to do that? And it also involves how do we recharge our water resources. We are only consuming, we are only some most of times we are also wasting without mindful of what is going on. So there is a need for conserving water. So water harvesting structures need to be planned at several places. What are the suitable sites for that? And once we do that, what is the impact of such structures? That needs to be assessed. And the rural asset inventory. Now in the rural areas, several assets are being mobilized under various government schemes. When I say assets, it is infrastructure components, the villages or panchayats or districts or whatever, under several schemes. Just to tell one or two names, probably most of you have heard Rural Employment Guarantee Scheme. It was there for quite some time, for last 2 decades or so. And now it is renamed as Mahatma Gandhi Rural Employment Guarantee Act, Manrega, Geo Manrega. So, as a part of rural employment, people are given assured wages and they are utilized for some work. As a part of that, some of the developmental works are being carried out using these village people. And some of the works, what they are doing, where they are doing, they need to be captured. So that is where this project talks about. We build some rural assets and we have some application which is a very good application. And then next most important thing is agriculture sector. In agriculture domain, we have very good applications. One is the crop assessment. In crops we have 3 seasons, predominantly 2 seasons, Rabi season and Kharif season. And in between Zaid season comes. And cropping pattern and crops, what are the crops being grown across spatially. And next surveillance, at which each place the sowing will be different. The same crop, sowing will be different. Maybe there is a delay of 1 week, 2 weeks, 3 weeks like that. Similarly, harvesting will be differing. And also the crop growth. So all this surveillance during the growth phase or during the crop calendar, that can be monitored using survey data. And accordingly, some guidelines or advisories can be communicated to the respective departments. The other important topic which took place in the last decade is Prime Minister Fasal Bima Yojana, which is crop insurance. Now almost all the state governments are also using this because farmers are suffering due to the damages for their crop in view of natural disasters. So that insurance, unfortunately, as most of you are aware, it is not happening in a proper way. What I mean is not in a transparent manner. So a lot of issues are there. I cannot tell. Whether the crop is really suffering due to the damage. So that can be assessed based on these vegetation indices. So, and secondly, yield estimate. They say they lost so many tons which they are expected to get. But is that yield true? What is being claimed? Is it true? So how to prevent false claims? So in that, for rate making, that is insurance premium, so clusters are defined based on geospatial stage and vegetation indices. They are the criteria based on which insurance clusters are formulated. So in this cluster, premium is something. In another cluster, premium is something else, based on the natural crop condition. So all this is done using vegetation indices. So I will show you one slide on that. And then water management. And one more important is agriculture drought. Maybe everybody must be aware of, most of the times we hear this word, when there is a delay in rainfall, and then it affects agriculture. So it leads to drought condition. If the delay is too much, it is called agricultural drought, because that necessary soil moisture is not there for the crop to grow. So the crop suffers, it may lead to wilting of crops. Okay, so that is another very important project. And in the recent past, one more new domain is bioenergy. I do not know how many of you are aware of, particularly in Punjab, if you see, and the northern states, what they do is they burn agricultural residue, particularly in the month of November or so, because that is the end of the season after harvesting. This agricultural residue is burned, and it leads to a lot of fog, and it is affecting even civil aviation. Flights are getting delayed due to fog formation also. It is a very big problem. And they do not know what to do with this, so they are burning. That's it. And it is happening elsewhere in the country also, but there it is very dominant. So, what is this agricultural residue at different places in a spatial manner? First, if you have an idea of this, can we generate fuel from this, which is a biofuel? So, in that context, we work, and it is very feasible, and there is a scope for industry to think of bioenergy plants, considering the availability of agricultural residue at different spatial units. And you are also roughly estimates are made how many metric tons of residues are available. So based on that, they can think of a startup or whatever. Some industry opportunities are available. Water management products, solutions. Here we have surface water dynamics. Now water is highly dynamic. Every day or every week it keeps changing. So wherever there is a dynamic nature, that is where the satellite data is very useful. Once something which is very stable over the decades, probably fine, it is only for planning purpose. But to monitor when there is a temporal dynamics at very regular intervals, satellite data is very useful. And the water spread dynamics, water infrastructure planning, monitoring, and hydroinformatics. We have a lot of infrastructure components in water domain. When I say infrastructure components, dams are there, check dams are there, and canals, irrigation distributaries, and control systems. So many infrastructure components are involved in irrigation system. All this needs to be mapped and also regularly monitored. So we are working on that. In addition to that, there is what is called evapotranspiration, soil moisture, and spatial and temporal water budgeting. This is very important, spatial and temporal water budgeting. Just like financial budget, water is also a resource which needs to be budgeted. What is available, what is being consumed, are we on the right path, are we consuming more, etc. This needs to be assessed so that you can take suitable conservation measures. In the irrigation side, in the context of food security, how can I maximize my food production? So if I can optimally use my water, I can increase my cropping area. So can I improve irrigation potential? So where I can do that? So in that context we can work on, we have done very successfully in some of the command areas. And village level groundwater resource assessment. At every village level, what is the resource available? And sustainable groundwater management plans. So these are some of the things, contributions in water sector. And now coming to the urban infrastructure management, in fact in the introductory part, the people were talking about urban management. Here, this is one of the important area in the recent past in view of excessive migration of people from rural areas to urban areas. There is a deficiency of urban infrastructure. there is a population shifting to urban areas. So there is a need for effective management practices and suitable developmental plans to develop these urban areas. When I say urban areas, the top A1 cities are one side, but now second tier, third tier cities are also coming up. So that is where we need to concentrate more, so that making a lesson from these big cities, how best we can have a developmental master plan for second tier and third tier cities. In that context, a GIS based master plan preparation has been addressed, and we have done a project for Ministry of Urban and Housing Affairs. And these maps are used by urban local bodies to develop the master plans using GIS. And there is another thing called municipal tax management solution, that is property tax. Now, particularly in Telangana, it is successfully used. So, what are the properties which are taxed? There are certain properties which are not taxed or which are under taxed. This is the problem. So, spatial data and the most importantly, the field data is collected through a mobile app, integrated with the spatial layer, and identified certain pockets where they are not taxed or under taxed. And the municipalities have gone there and recovered it. They made a big revenue of that 2 years back. It was also a very successful case study. And forest resource management. Here, forests are very important in the context of biodiversity and to maintain our ecosystem. So, forest is lost for various reasons. Sometimes a natural forest fires, sometimes anthropogenic and man-made fires. So these need to be checked. And what is the forest biomass? Forest management plan. So these are the things which we have been working on. Geological resource management. When we say geological resources, we have groundwater as a resource and also mineral resources. We have several minerals across the country in different pockets. Now, what are the potential areas where these minerals are or they are expected to be? That can be studied based on surface features depending on the geological formations, folds, faults, or unconformities, or whatever. So, based on the surface features, we can say that there is a potential for this kind of mineral in this region. And that means we are trying to shortlist the areas. And in these shortlisted areas, further investigations can be made to precisely identify the mineral spots or mineral resources. Same is the story in the case of groundwater. Now, disaster risk reduction. Whenever there is a disaster, when I say disaster, that includes the cyclones, floods, forest fires, landslides. So, when these things are happening, how to help the local organizations for minimizing the damage or to carry on the relief operations. So for local relief commissioners of the states, we immediately transmit the data. We take the satellite data in near real time as soon as the event occurs, and we process it, and we try to give what are the areas which are affected or which are inundated, and accordingly the suitable relief operations are made. And also in the case of Godavari River Basin, early warning system has been developed. So we are trying to give an early warning that there is a flood expected in the next 6 hours or so. So that is one thing. And based on the historic flood events over the last 3-4 decades, based on the frequency analysis as well as intensity of the flood, we have formulated and developed flood hazard zoning. Flood hazard zoning atlases are developed for different river basins, and state-wise they are segmented and they are handed over to Ministry of Home Affairs. So now little more details about land resources. As I said in the beginning, land resources inventory and monitor. Is it okay or am I boring? I am not saying the people like me. Is it fine or should I reduce or increase? No response. You are fine? land use land cover mapping. It is done at multiple scales. 1:250K, 1:50K, and 1:10K, and at different time points. And these are for a regional planning or for a rough idea. They help in any domain, in any developmental scheme. And this 1:10,000 is very useful at the village level. To formulate any village level developmental plan, 1:10,000 scale LUS will be useful, which is generated as part of SDP program. Okay. And there is another thing called wasteland mapping. I am not getting into the details how this is done. Okay. Wasteland mapping. Now there are several wastelands across the country. That means they are of no use for any specific crop or anything. So what are the wastelands available in the country? And why are we doing that? Can I transform these wastelands for any effective use? That is the question. First, if I know what are the wastelands, how best I can use? So probably many special economic zones, and just to tell you on this, our high-tech city is a part of wasteland. It was a wasteland. It is allotted and now it has come out as a high-tech city. No, agriculture cannot be done. No other meaningful purpose which are well known, they cannot be done. But they can be developed for such SESSIONs or such other industrial activities, depending on suitability. So that's where wasteland mapping and inventory is very useful. Instead of spoiling the agricultural pockets, let us see if we can use wastelands for the purpose of development. And in addition to this, land degradation. What do you mean by land degradation? The land is getting degraded over the years due to excessive water inflow runoff. When the water velocity is more, it erodes the soil. That is case one. Similarly, in view of excessive fertilizer usage and all, salinity will happen. Alkaline, it becomes alkaline. It is no more productive. After some time, that land is no more productive. It is degraded. And sometimes, in some cases, wind erodes the things. Or sometimes, due to the coastal weather or maybe cyclonic storms or say flooding events, waterlogged areas, heavy waterlogging for a longer period can damage the soil. It makes it unproductive. So these are some of the reasons for land degradation. So what are the degraded lands? And how can we reclaim that? At least a part of it. Is there a way to reclaim? So that is the focus of this. Any questions?
Whatever you are talking about, is it only for predicting, or will there be any solution from geospatial analysis?
What I see is not a prediction. What is required first is how much of it is already available as an inventory. First you map. I tell you the essential steps for any domain. First you map the particular feature. Then you are making an inventory depending on the application you are talking about. Then comes the question of how to reclaim or rectify or whatever. Now the prediction is ultimate. Unless we have developed enough data sets, enough volumes, then you can think of prediction, which as of now, no. It may take some more time, and that is where these new technologies may help us. Now based on the spectral libraries, now the beauty is we have beautiful spectral libraries mobilized over the years for all these features at different spatial units. Now with AI, probably you pick up these spectral libraries in multiple pockets, understand how the reflectances are changing at a pixel level, and see if you can classify. And historically what we have done, that can be used for training your algorithm. And you test it on some other pockets and see. If required, collect some more data, improve your training set, and doing it. It's an iterative process. Now most of you should be aware of it. So iteratively generate more and more spectral characteristics and libraries for a specific feature and see if you can address and solve this problem at a country level. Now what we are talking at a study area level. It may be a district or it may be a basin or a sub-basin or whatever. But what I am doing here, I cannot straight away apply to other regions. Again, I have to do the classification process. For a different study area, when I do, I have to download the data, do the routine steps, and classify, etc. So all steps will follow. Instead of that, can I employ AI? So that is the question I am going to touch upon at the end. So in every domain, we have beautiful data sets, and already you have labeled it. Labeling is one important thing. So you have labeled it that this is a particular feature. But now can I extrapolate to other parts of the country? So what sort of algorithm is required? Train your ML or deep learning algorithms to do that. That is where the opportunity comes, and that is where the research question is there and the opportunity is also there. Is it clear?
Sir, can
Yeah.
you just provide a glimpse about spatial and spectral analysis? Because most of the audience would not know about what is that.
Spatial and
What is
spectral.
analysis?
Great. I will just touch upon for 1 minute since you raised it, but afternoon there is a specific session by Anjaneyalu. He will be touching upon remote sensing techniques now. Probably he will be addressing more. So what is spatial? Spatial means now this auditorium is there. Is it visible? Is it separable from satellite data? Or let's say a car is there here. Assume auditorium and a car. Is car visible and detectable in the satellite data? A car is detectable if my spatial resolution is of the order of few centimeters. Let's say less than half meter, because car is expected to be about 4 meters, 5 meters length. So at least I should have 5-6 pixels to identify an object. That means my spatial resolution should be of the order of half meter or something like that. Then a car is That is the second part. These are addressed in soil health part. Now this is the bioenergy I was touching upon earlier. All the agricultural residue can be transformed into energy by suitable processing mechanism. This is where a good scope for industries. And now I will go with the water resources applications. Surface water spread as irrigation infrastructure potential. Irrigation infrastructure potential, all the infrastructure components of irrigation are mapped, and if you see on the middle black and white, you are able to see some yellow lines. This is a program which we have done using Cartosat data, which is 2.5 meter spatial resolution. So what is done is, as an accelerated irrigation benefit program of Government of India in 2008-9, they have funded heavily to the state governments to construct canals for distribution of water. And whether canals are actually constructed or not, that is the question. So that's where satellite data helped. So now satellite data is being used for financial payments to assess whether it is physically done or not, as a verification mechanism. And whether a canal is there or not, based on the hydraulic conductivity principles, we have mapped it. And still, in spite of that, particularly when there is a tree shadow or other shadow regions, particularly in Kerala and other parts of the place, we could not see properly. So we had to go to the field to confirm whether it is correct or not, certain pockets. So field verification was done in certain pockets, but otherwise most of it is done through satellite data only. And it was well utilized, and it is continued even now of non-new commands. And on the bottom left, snow cover. So in Himalaya, snow cover, it's a regular seasonal thing. On daily basis, there is a change in snow cover, on daily basis. And how the snow cover is changing on a daily basis is captured in the time series data. And then the next one is water informatics. All the water resources related information, including infrastructure components, are archived as a web application under India Varis web portal. Anybody can see this, India Varis, and it is available on internet. And water availability assessment. Historically, water, how much of the water is available? 1869 billion cubic meters. It is assessed very old, using empirical and conventional methods. But is it valid? So we have reassessed. Glacial lake inventory and the GLOF risk assessment. Glaciers, anybody is aware of glaciers? So glaciers, there are several lakes in Himalaya. Some of those lakes are not stable. They are outbursting, resulting in flooding, and some damage takes place in Himalaya. So what is the risk of these GLOFs? So what are the water bodies or glacial lakes which are vulnerable for such burst? That is what is addressed in this project. And then irrigation water management. Now here it is Narayanpur command in Karnataka. So the crop map and irrigation requirement. If you see on the bottom left, again in this image left side green pocket, that green is what? Crop map, which is essentially rice. That green is paddy. And on the right side again the corresponding pockets are red. If you see, what is that red?
it is demanding more water. So based on the field crop condition, what is the water required in this pocket, I can make an assessment, because if it is paddy, I know what is the crop water requirements based on hydrological principles. So I can estimate this is the water required, therefore this should be your water distribution management practice. We can have a good water release plan with irrigation engineers in the field. So that's where optimization of water usage comes in. National Hydrology Project. This is a big project going on for last 10 years in the recent past with the Ministry of Water Resources funded, and also World Bank is involved in this. So here there are essentially 8 components plus training component, that is capacity building. So irrigation scheduling, glacial lake outburst, spatial snowmelt runoff product, and the national hydrological modeling, spatial flood early warning system, web-enabled hydrological modeling. I'm not getting into the details. The list goes in a big way, and the time is not sufficient. Any questions? I think nobody is asking questions. Either you understood completely or you have not understood anything. Fine. Forest applications. What are forestry applications? Forest laws. Whenever there is a forest fire for any reason, sometimes it is a natural forest fire, sometimes it is manual. So, and using MODIS thermal data, thermal sensor is available in MODIS. So we have built in a mechanism such that the data is captured around 10:30 AM at the country level. In that day, whatever the orbit that is covered, the data is dynamically processed on our servers based on thermal data, and temperature alert is picked up, and the local sites are given alert within 2 hours that there is a fire alert in this pocket. It all happens on board, not on board, sorry, in our processing servers. So by 12 o'clock, 1 o'clock, the information is disseminated to the local forest organizations. And biodiversity, and how do we conserve that? There are multiple species, stand and stack of the forest trees and other things, and how the different species are distributed and aerial spread, etc. So to conserve the biodiversity. So in that context, we have a good project with the Department of Biotechnology. Biodiversity monitoring. So as a part of that, the biodiversity wise, what are the changes? The canopy wise, what are the changes? Canopy geometry, etc. can be captured from satellite data. So that can be done. Geological applications. Initially, I have given an overview. Different groundwater prospects, and this is a very good. I think 80% success. That these approximate areas or potential areas are mapped using satellite data, and when you drill a bore well there, the success is about 80% that you get water. And again, quality wise, we have done some good work as far as quality of groundwater is concerned. And in addition to groundwater, as I said earlier, mineral prospects. What are the suitable pockets for mineral prospects? So that is also done using satellite surface features. In addition, landslides, which is one of the disasters, natural disasters. Whenever there is a landslide, what are the areas which are affected? And based on this history of landslide areas, we have done hazard zonation maps. Because in Chamoli district in Uttarakhand or in some areas, it is very frequent problem. Landslides are very frequent. So it is a regular event. Even tourism is affected because of this. So all highways are affected because of sudden landslides. So it is very costly. In fact, locally it is a big disturbance. So in that context, what are the hazard zonation is done, so that whatever is possible you can avoid those pockets, particularly in monsoon period, because monsoon period is very favorable for landslides. Now, urban applications, we have urban master plan preparation. As I said earlier, using GIS as well as satellite data, we can prepare master plans, and for this purpose at 1:4000 scale it is done, and it is done under Amrit project, Atal mission for rejuvenation and urban transformation, that is the full name. So in that we have done, and it is done for about 250 cities, and it is expected to be added to 4000 cities across country, as I said, tier 2, tier 3 cities and all. And also Gale pipeline monitoring. Now these gas pipelines, gas companies, they have their pipelines transmitting their gas. Now the problem is, if anybody mishandles, and these pipes are underground, say by about 2-3 meters deeper. Now if anybody knowingly or unknowingly does anything there, it affects the entire pipeline system. So this pipeline corridor needs to be monitored if any untoward incident is taking place. So that is one project which we have done, and it is expected to be continued by the company itself or the organization itself. Now how the urban area is growing on the top right, that is for Delhi city, how over the time, maybe every 5 years, if I take a picture, how is it growing, in which direction it is growing. So that's what is indicated there. Yeah. So the one more important project in urban domain is urban water body information system. Here now this is the hot topic for Hydra. Okay, so urban water bodies, many of them are encroached or damaged or whatever. Lot of other things are happening, everybody is aware of. So what are the water bodies first? And then, so what are the water bodies? And then what is happening around the water body? That is very important. Now most of the time, part of the water body itself is occupied. Forget about around the water body. So to prevent this and to conserve these water bodies, what sort of action plan needs to be taken? For that, a base information is required. First we should understand what is the water body and its neighborhood. So in that context, we are doing this project. This will be a very useful information for the regulatory people or government or Hydra or whatever to take suitable actions. I think there is a request for a short break. We can break for 5 minutes, 10 minutes. But are you fine or should I stop? I think I may take 10-15 minutes more. Probably if you can have a break, then we can resume. I think many people are not so active. They need some tea maybe. So we'll break for 5-10 minutes. Any questions?
Sir, how to collect data from these all the things? Data set. Data set.
Data set.
How to can be collected from the website like that?
Who will report the
Free of
You can test the registration.